All right, this video is for Learning Target 1, Unit 2, which is all things linear. There's a few Algebra 1, well, several Algebra 1 review topics embedded in the unit and even in this first target. So we started with a bell work that I wanted to at least do for the video. These are two Algebra 1 problems, one equals, one inequality, to kind of warm up. First step, we distribute the 3 and get 3 times 2, 6, plus 3 times x. And then we carefully distribute the negative 5, which will be negative 5 times x, negative 5x. But this one was missed quite frequently in class. When you distribute the negative 5 to the negative 2, it becomes positive 10. Then we combine our like terms of 6 and 10, get 16. The 3x and the negative 5x makes negative 2x. Then we start subtracting and moving things to the other side of the equals to solve for x. So we subtract 16. And we get negative 2x equals negative 8. Then we divide by negative 2 and get x equals 4. Much the same steps for solving an inequality. First step over here would be adding 5. So negative 2x is less than 6. But then when you divide by a negative, you have to flip the inequality. So this becomes x is greater than negative 3. Real quick, it's not some random thing you memorize in math. The nature of 2 and 5, 2 is less than 5 when you compare those two numbers, but as soon as you divide both sides by negative 1 and you compare a negative 2 to a negative 5, you'll notice that negative 2 is greater than negative 5. So it's just true that when you divide by a negative to both sides of an inequality, you have to flip the inequality. So kind of what we did there. And I know I'm going through this really fast, but it's for the sake of the video. You can pause it and rewind. But that's Algebra 1. Another Algebra 1 concept was you graphed your answers from time to time. So we'll say 0, 2, 4. And this is important for today's Algebra 2 lesson. Negative 4, negative 2, 0. When graphing x equals 4, you just graphed x equals 4, 1 point. But when you're graphing x is greater than negative 3, there's an infinite number of solutions. Anything bigger than negative 3 needs to be relayed or communicated to the reader. So you do that by saying, all right, anything bigger than negative 3, but not including negative 3, open circle at negative 3 to tell the reader that negative 3 does not work, and then shade everything to the right. All right, and then last, I'll come back to that. We'll go on to the notes. For Algebra 2, we're going to be solving compound inequalities, so like bell work number 2, but we're going to have two inequalities separated by an and or separated by an or, and then graphing the solution set. So number 1, x is less than or equal to 5 and x is greater than or equal to 1. With an and, you're finding where these two different solution sets intersect. So what I like to do is graph x equals 5 and bigger, graph x is greater than or equal to 5 using kind of scrap paper, if you will, above the number line, and graph x is greater than, wait a minute, I'm sorry. If you were just watching me do that, that was probably confusing. Sorry about that. X is less than or equal to 5 should have been a solid circle at 5 and shading to the left. Sorry about that. And then graphing x is greater than or equal to 1. Solid circle at 1, shade to the right. We're going to look at where they intersect or overlap. What are the numbers that work for both of the two individual solutions? Well, anything bigger than 1, they overlap starting at 1 and going to 5. So starting at 1 and including 1 all the way to 5, shade in between. So your final answer is anything between 1 and 5. Those are the numbers that'll work. Think about it this way. Give me an example of a number that is less than 5 and bigger than 1. Less than 5 and bigger than 1. You might say 2 or 3 or 2.6, 2.5. So that's kind of how that works. Number 2, x is greater than negative 2. So open circle at negative 2, shade to the right. X is less than 3. Open circle, shade to the left. Just a quick reminder, it's always open circles when there's not an equal to, because you're telling the reader that 3 3 is not less than 3, so you put an open circle at 3. All right, and again, it's an and problem. So with it being and, where do these two overlap? Well, they clearly overlap in between -2 and 3, but they do not overlap at -2. -2 works in this inequality, but it does not work in the second, in that inequality, because -2 is not greater than -2. So on your final answer, put an open circle at -2 and an open circle at 3, shade between. Number 3, x is greater than or equal to 2, so solid circle at 2, shade to the right. X is greater than 5, open circle at 5, shade to the right. Where do these two different solution sets overlap or intersect? They overlap starting at 5, but not including 5, and to the right. Number 4, x is greater than 5, so open circle at 5, shade to the right. X is less than 2, open circle at 2, shade to the left. Where do these two overlap? Well, they don't overlap at all. So there is no number, and that makes sense. There's no number that's greater than 5 and smaller than 2. No number exists, so no solution. You don't shade anything on the actual number line. By the way, that's what I'm going to grade and look for, is what have you shaded on the number line. You can do all the scrap work you want above the number line. Scrap work being those green shaded regions. But whatever's on the number line is going to be graded for your final answer. Number 5, scrap work, x is less than 3, so open circle at 3, shade left. X is less than or equal to 0, so 0 is included, shaded circle, and shade to the left. And the question becomes, and, where do they overlap? They overlap starting at 0 and to the left. So closed circle at 0, shade to the left. Final answer. All right, now, disclaimer. Most of the homework is not going to look like 1, 2, 3, 4, or 5. Now, that's not to say you're not going to need it. Most of the homework is going to have a few Algebra 1 steps, like this bell work problem had, before you get to x is greater than -3. So an actual homework problem would look more like this. 2 minus 3x is less than or equal to -4, and 3/5 x plus 4 is greater than 7. So you'll have 2 Algebra 1 problems to solve, and then it will become a problem like we practiced in 1 through 5. In fact, this one, if you want to pause the video, should turn into an answer that we just got in 1, 2, 3, 4, or 5. So if you want to pause it now, and then you can come back and check your work. First step would be, that's a positive 2, so we're going to subtract 2 to both sides to get x by itself. So -3x is less than or equal to -6. Divide by -3, and if you divide by a negative, you have to flip the inequality, and -6 divided by -3 is 2. I'll go ahead and bring the word down, and, so I don't forget. And then I like to get rid of fractions in my first step, so I'm going to multiply everything in this entire problem times 5, the denominator of the fraction. 5 times 3/5 is 3. Those 5's cancel. So 3x, 5 times 4 is 20, and then multiply the other side times 5, greater than 35. Then I like to solve the x from there. So that gets rid of the fractions. Subtract 20, 3x is greater than 15, divide by 3, x is greater than 5. And you'll notice that that is problem number 3. So problem number 3, that's our answer to the homework example. All right, so you'll have to do a little bit of Algebra 1 to solve for those x is greater than or equal to 2 and x is greater than 5, but then use the Algebra 2 to combine them on the number line. All right, numbers 6, 7, and 8 deal with union, or deal with the word or. First, we'll do our scratch work. X is greater than or equal to 6, solid circle at 6, shade right. X is less than 2, open circle at 2, shade left. But that word or is important. I'll take any number that is greater than 6 or less than 2, meaning the number 8, let's just take x equals 8, for example. It works over here. X is greater than 6. But it does not work in x is less than 2 because 8 is not less than 2. But the fact that this is an OR, as long as 8 works in one of the two, it belongs in the final solution set. So anything greater than or equal to 6, all of those numbers are in the final answer set. So are any of the numbers that are smaller than 2. So any number, open circle 2 and left, are part of the final answer, meaning we just take both of those solution sets and include them in our final solution set. Any numbers less than 2 or greater than 6 are part of our final answer. So with OR, it's the union of the two sets, or kind of like the addition of the two sets. You put the two sets together, kind of add both of them up. Scratch work on number 7, x is greater than 1. So open circle at 1, shade right. X is greater than or equal to 4, solid circle at 4, shade right. And what are the numbers that work in x is greater than 1 or x is greater than or equal to 4? If it were an and, we'd be looking at where they overlap. But let's just take, for example, the number 2. The number 2 is greater than 1, check, but 2 is not greater than or equal to 4. Should we include the number 2 in our final answer? Yes, we should, because it only has to work in one of the two solution sets. So we should include 2. Well, if we're going to include 2, then that means we're going to include 3 because it works over here. The bottom line is we're going to include any number that fits this one or this one. So we're going to take anything bigger than or equal to 1. Kind of like the addition of the two sets. When you graph greater than or equal to 1, you're graphing greater than, when you graph greater than 1, you're graphing greater than or equal to 4 from here on. Number 8. So that's our final answer. Number 8. X is greater than 4. Open circle at 4, shade left. X is less than 8. Open circle at 8, shade left. If this were an and, we'd be looking for where they overlap. But this is not an and, it's an or. So any number smaller than 8, so anything to the left works, and anything to the right works. So we're going to end up shading everything. Everything works here. This is an example of an all real numbers. All right. And I'm going to stop the video at this point, which just is a basic introduction to Learning Target 1. And I'm going to use these completed notes to explain set builder notation and interval notation in a separate video in case you just need to watch that video.